Okay, in this video I'm going to be going through past HSC questions that relate to work and power. So I'm going to be starting with work and then moving across to power. So if we look at, before we get started, we'll talk about in the last HSC, this was what was in the formula sheet. Work equals force times displacement, but it's also equal to the change in kinetic energy plus the change in potential energy. Now, for those formulas, work equals force times displacement. It's important that you remember that if you lift something up, we're only interested in the work. The mass is only, the weight is only relevant. The mass times gravity is only relevant when you measure the displacement in the vertical direction. If we're moving something horizontally, the only thing we care about there is the energy that goes into friction, right? It's mass times friction in that case that we're concerned about. That's our force that we're going to be interested in. So it's really important that when you think about work, that if you're thinking about friction or if you're thinking about the potential energy if you're lifting something up. Now, I hope that made sense. It was a little bit rushed. Okay, so here, in the case of potential energy, potential energy is only the vertical displacement. That's the only part that we're interested in. Another word for vertical displacement is height. In this case, we're allowed to use the force as equal to the mass times gravity. But in any other situation, if something is not being moved vertically, we will be considering its friction, the resistance to motion, which is going to be friction. The other formula, which you just have to remember, it is on the, well, not have to remember, you just have to be able to apply. It's on the formula sheet, is kinetic energy equals half times mv squared. Just learn that formula, just learn it. Okay, now in the Copeland textbook, he rewrites that formula in a different way. We're going to have a look at that here. So he says that the initial potential energy plus the initial kinetic energy plus or minus the work, because we don't know if we're pedaling in our bicycle, we're going to be adding work. But if we're sliding down a hill, we're going to have friction that's going to resist us and that's going to be negative work. So it's important to know whether or not work is being added or work is being subtracted in these formulas. That's going to equal our final potential energy plus our kinetic potential energy. Let's look at this situation here. So here we have in the HSC 2014 question 14. HSC 2014 question 14. There's probably some letter involved, but you'll be able to find it from there. What we have is, no, it's a multiple choice, that's why. We have it's a vehicle of 2 tons. That's what the question said. I've transferred that, I've drawn this diagram, and I've transferred that, so it said 2 tons in the question, and I've turned it into 2,000 kilograms. That's the mass. They told us that the slope is 20 meters long, the incline is 40 degrees. Now, what we need to do is we need to determine the height. So someone who's got a calculator, can you calculate? While I explain the very basic trigonometry. No, I don't like to do too much trigonometry, but let's see. What we know is SOHCAHTOA. Well, we're finding the opposite side of the angle, so we want to use sine equals opposite over hypotenuse. That's the SOH part. We can rewrite that formula. Now, I was in year 11 before I learned how to rewrite this formula as opposite equals hypotenuse times sine. I just winged it every time and got it right 50% of the time. So I've rewritten that as opposite equals hypotenuse, which is 20, times sine, 40 is the theta. What number do we get?
12.86.
12.86 meters. Okay, so that is the height of the height that we can use for our calculations. Now, what we've said here is if we look at this situation, the vehicle at the top of the hill has potential energy, but we're considering it to be stationary. That has no kinetic energy. Now, we're being told to ignore friction in the question, assume that there's no friction, and so then what we're going to do is, that's going to be, so effectively here, in our case, potential energy is going to be equal to kinetic energy, because where our potential energy at the start is going to be equal to the kinetic energy at the end. Kind of like a pendulum, if you take a pendulum at the start, it has 0 kinetic energy but full potential energy. At the bottom of its arc, it now has full kinetic energy and no potential energy. Quick demonstration. This has potential energy, but it's not moving, so no kinetic energy. At that point, at the point that it hit there, before I slowed it down, it had maximum kinetic energy, but it had no gravitational potential energy. So that's what we're going to be in our situation. Now we're going to take those 2 formulas that we have here. PE equals mgh, and kinetic energy is going to equal half mv squared. Half over W. Okay. the question, I believe, is asking us to find the velocity at the end of the thing. It's asking us to find velocity. Okay, so what we can do here is we can rewrite this formula. To rewrite this formula, what we want to do is we want to bring this half, let's get rid of the half to start off with. If we multiply both sides by 2, we get 2mgh equals mv squared. Then what we can do is we can divide both sides by m. When we divide both sides by m, what we get is 2gh equals v squared. So to get v, we want to do the square root of 2gh. So our velocity is going to equal 2 times gravity, which we're going to say is 10, times the height, which is 12.86. Can you do that in the calculator?
16.0. Yeah, 16.
16, and that answer is going to be in meters per second. Now,
Plus minus. So not.
that's
Well,
like that. Oh, okay. So with a question, I had a student say, well, because when we square root things, theoretically, minus 16 times minus 16 would also give us that same answer, and that's true. You just can't have a negative velocity, right? In physics, it's...
Yeah, he told us different.
Oh, okay. Well, maybe it's possible to have a negative velocity. For me, I'm going to run with this answer. That's the answer. That's one of the multiple choice choices, and I'm locking in D, Eddie, for that answer. Okay. So we've done our first question. This is the only real work question I think that we look at. The next ones are all going to be power questions. So I'll clear the board and we'll get started. Oh,
Absolute kings.
I don't think I need that. I'll rewrite it if I need it. Okay. So the next one we're going to go with. We're going to go in chronological order, or what do we want to do?
Start left, go right.
Okay, we'll do 2 work questions. We'll do these ones first. Okay, so we'll do the 2002 question 13A. And what it says is that we have a bus that needs to be lifted. It needs to be lifted at a height of 250 millimeters, which we're going to use SI units. We're going to say that the height is equal to 0.25 meters. And we've got the mass of the vehicle, the mass of the bus is 3 tons, which we're going to convert tons into kilograms. Right? You have to know that. And we've been told that it takes 10 seconds, 5 seconds. Now normally really the unit is S, but when I'm writing on a board it can be hard to see that that's an S, so I've written sec just to help you out there. Now the formula for power equals, well, it can be multiple things. It's work divided by time, which is Fs divided by time, which can also be written as Fv. Now in our case, we've been given all the details in that formula there. So we're going to say power equals, the force is the mass of because we're going vertically, work is going to be, it's going vertically, so we can use the weight of the vehicle. Yeah? So we're going to take 3,000 multiplied by 10. It's going to take 5 seconds, and displacement is 0.25. Now, to me, to simplify that, I might try doing that as, so I'm going to have 30,000 divided by, I'm going to put that as 1/4. And if I put that as 1/4, I can do 20. 30 divided by 20,
1500.
okay, let's see if I can find the answer for that one. What year were we looking at? Question 13? 1500, and what unit is that?
Oh, it's
1500. What's the unit? Watts. There we go. Okay, so that's the correct answer. Okay, so the next question that's related to that, it's a very similar sort of question. Is we're going to do the question 11. Now, I don't know what question this came from. It's something in the question 11, and I can tell you it's part C. If I was better at this and more organised, I'd be able to tell you what it was. But it's question something, and it's BI. So from that, you might be able to find it. It's worth 2 marks. And what we're being told is that we have an object that's being lifted, and yeah, hello? Hi. Can you Thank you. Thank you. Okay.
Wait, and you didn't. This is
babysitter.
What?
I know. Mrs. Babista in the office straight away.
Mrs. Bates.
Barista.
I'll be back.
Okay.
That's good.
Oh, good. Okay. I was just looking at my question and I wasn't sure I'd written down the details properly. So in this question you can see a conveyor belt, and the conveyor belt tells us it's 9 meters high and 20 meters long. We're told that the object that's being lifted has a mass of 115 kilograms, and a detail that I didn't write down. Oh, I did. There we go. Time equals 25 seconds. Now, in this situation, we're going to look at again. Power equals work times
On time.
work divided by time, which is equal to force times displacement on time, which is equal to FV. Now, in this situation, we're going to look at our force that we're lifting is going to be the weight. We're lifting this object vertically. Now, we don't really care about that 20. All we care about is how much we're lifting it vertically. Because there's no friction in this system, so F we're going to use in our data. We're going to say F equals W or mg. Now, I don't like to use W because it gets confused. So in our case, it's going to be 1,150 newtons. Okay, our time. So if we want to use, we'll use S over T. So the displacement that it's traveling is going to be 9 meters, and our time is going to be 25 seconds. So in that case, it's a fairly simple formula. P equals 1150 times the displacement of 9 divided by 25 gives us, calculator?
414.
414. Yes,
Watts as
and,
well.
and it's in watts. Excellent. Okay, so that question's done. We can now move on. So that was fairly easy for 2 marks. Okay. The next 2 questions we're going to look at are both on flat surfaces. So we'll see which one I find first in my notes.
Question 16. What? No, 2016, question 22.
I'm just going to go, just because I like to be able to follow along and check that I'm writing things down. Do I have 23 there? Yep, let's go with that one. Okay, so question 23 from the HSC 2016, question 23C. And what it tells us, it's worth 3 marks, and we've given an object, and we're told that we're given a mass.
No,
No, okay, we're not given a mass. So what this might make our question more difficult. So, or will it? So our velocity is given as 90 kilometers per hour, and we're also told that there's a force that's resisting it of 18 kilonewtons.
Would that be friction?
Yeah, that would be the friction that, it's the power that's required to keep the vehicle moving at a constant velocity, in which case that is friction. When the power that's being applied keeps it at a constant velocity, means that the force we're applying is equal to the force of friction. Okay, so in this formula, we don't have time, we don't have mass, so what formulas can we have? We can say power equals force times velocity. Fight the power, Fv. Okay, so we know force, we've given the force, which is 18,000, and we're told a velocity of 90, but we can't just use 90. Like Ed Sheeran, what number do we need to divide by?
3.6.
3.6. Why are we doing that?
Convert it to meters per second.
To convert it to meters per second. So when we get that, so we're going to get 25. So 18 times 25 equals 450 kilowatts. You got that as well? Okay, 450 kilowatts. Okay, so we're done with that question. Next question we're going to go to is from the 2007 paper. And it is question, we don't know, but it's a C. And it's I. And it's worth 2 marks. And we've got a similar situation. They've told us that, in this case, they've told us that the vehicle is, they've told us the power required. So they've told us that P equals, what was it? 300 kilowatts, yeah, okay. 300 kilowatts. And what they've asked us is to figure out what that friction is. That friction this time is an unknown. They've told us that the vehicle has travelled 1 kilometre, which is 1 16,000 meters.
Minute.
And it told us that we did that in 1 second, 1 minute, which
1
is
minute.
60 seconds. So when we take that velocity, we convert it, what are we going to get?
16.7.
16.7 sounds right. Okay, so in that case, we're going to rewrite our formula. P equals Fe, fight the power Fe. We want to find F, so in that case, we're going to divide both sides by V. So we're going to get PV equals, and that V crosses out, F. So F equals P, which was 300 times 10 to the 3, and then divided by 16.7 gives us
17,964.
17,900, so pretty close to 18.
Yeah.
Yeah, 18,000 newtons.